Welcome back. We are looking at the third chapter, 10.3, on how does the transfer of heat energy occur. If I know the primary school syllabus, science syllabus, I believe we've already learned about these three ways, okay, of how heat transfer. All right. So they are conduction, convection, and radiation. We're going to learn more about this for today. All right, so right at the bottom of this slide, you can see the very first way of how heat is transferred is by conduction, which I think we experience most of it in our daily life. But using the textbook and the notes here, okay, what you can see below here in this diagram shows that there's a metal ladle, okay, inside a hot pot of hot soup. Wow. Okay, so you know the heat will transfer from the heated end of the ladle, which is actually in the hot soup. And what will happen? It will then, right, the heat will then transfer up to the rest of the handle of the ladle, right, which is furthest from the source. Okay, so if you touch the handle at the other end of the ladle, you feel that it's hot after a while. Okay, and this method, this way of transfer is called conduction. Okay, but the meaning is more important. Okay, the meaning I already highlighted in yellow. So the actual meaning of conduction means is the transfer of heat energy without the physical movement of the medium. It means in this case of the metal ladle, the metal particles, which is the medium, they don't move, right? Heat just pass through inside the medium. Okay? So this is the meaning of the conduction. Now you look at the next part on the right side. Okay, there's an interesting scenario here. Okay, let me just guide you through. Okay, what you see here is that a can and a carton. Okay, of course, I think you know a carton here means it's made of cardboard, right? Not metal, huh? Okay, it's taken out from a refrigerator at the same time. Inside the fridge, of course, it's cold, huh? Okay, so what happens if you touch both can and the carton at the same time? Which one feels colder? Why? Okay, I think is related to the idea of conduction, but also knowing about metal and non-metal. Okay, let's finish with the explanation below. Okay, the can, like I said, is made of metal, while the carton is most likely paper-based, okay, paper source. Obviously, okay, so let's finish. Metal, of course, is a better conductor of heat, right, than paper, which is a non-metal. So this is actually linked to chapter 2, right, in the segment under physical properties of metal, right? Metal is a better thermal or heat conductor than non-metals. So later you see in the next slide, we're going to repeat that. So because of this, heat energy is conducted away from a hand more quickly, right? Because there's more heat in your hand than in the can or the carton, right? And being metal, the can will conduct the heat away from your hand quickly. And because you lose more heat from your hand to the metal can, how will you feel? You will feel colder lah. Not so much when you hold the carton, right? The milk carton. Okay? So better conductor transfer heat away from your hand quickly, and therefore you feel cold. Okay? We will see you explain further in the next slide. Alright, so let's continue from the earlier slide. Okay, right on the top, you can see actually in the table that shows you about good conductors and poor conductors of heat, which actually basically I think most of us are aware of it. So for good conductors, these are mainly your metals, right now? Metals, okay? Which actually we will have an experiment to show, or video on an experiment to show this later on in chapter 10.4. Okay, on the other side of the table is the poor conductors of heat. And if you look at the first point here, these are your non-metals. Okay, non-metals. And what's below? You can see there is actually the other two state right now, liquid and gaseous state. Right, of course, for this earlier part here, these are your solids, but non-metal solids. And for your metal, they are also solids. Okay. Interestingly, when you look at the video or the presentation on chapter 10.4, you will see an experiment that highlight water is a poor conductor, okay? To show that water doesn't conduct heat well. Okay, which you see that in the chapter 10.4. Okay, now let's go further down to look at this part, which is a bit more detail on how solids generally are better conductor of heat than liquids and gas. Okay, fluid is actually, when you see the word fluids here, it means liquid and gases. Okay, this one word represent both. Okay, liquids and gases. Okay, now what we understand is that if we look into solids, the particles in the solid, okay, you can see in the picture below, they are all arranged closely together. So the particles here refer to the circle inside the rod here, okay? So for solid, they are all packed, right, side by side together, okay? But in the case of liquid and gas, not so. Okay, there's no, I don't have a picture to show you that, but you will come to know this in another chapter. My apology for the alarm disruption. So let's just continue for the final part here. Okay, I want you to concentrate on the diagram now, okay, to try to explain conduction taking place in solid. Okay, it's not too difficult, okay. Okay, now heat is being supplied to the end of the rod here. So the particles at this end will gain the heat energy, right? What happens is that because the arrangement of the particles are very close together, this heat that they absorb will then be quickly transferred, right, towards the other end, which is at the cooler end, right? And remember, heat always transfer from hotter part to the cooler part. But in the case of solid, because of the particles arrangement, they are being transferred very quickly. Okay, very quickly. Okay, of course, then the distinction between metals and non-metals is another part that we need to learn, but not at the moment. Okay, hope this is easy enough. Bye. Okay, now we're going to look at how convection transfer heat in fluid. Okay, earlier we talked about conduction, all right, but now we're going to look at convection. Okay, so what is the meaning of convection? Okay, this is right at the beginning. We are already explaining what it means. Okay, convection is the transfer of heat energy. Okay, the three methods, so all started with the same term, transfer of energy. But how is it done? Okay, is from one place to another place by the physical movement of a medium. What do you remember about conduction then? What's the meaning of the conduction? Okay, if you cannot remember, I've placed it right below here, okay? So you compare the two meanings. In the case of conduction, there is no physical movement, but in the case of convection, the heat is transferred because of the physical movement. Okay, in this case, the medium here can be liquid or gas, which is actually stated earlier on, fluids. Okay, so that's why only in fluids you can have convection, not in solid. Okay, the solid, the particles, or in the medium, those particles cannot move. Okay, only in fluid. Right? So there's quite a bit to explain. So let's continue. So this is quite a standard experiment which is done, right? Which I'm going to just quickly go through. But before that, actually there's a very good video that shows exactly this experiment. Okay, you can go to the video section, okay, or use this link to go and look at this video. Okay, let's come back and let me explain as much as I can on this part of the slide. Okay, so we're going to start with the part here. Okay, so we have a beaker with water inside. Okay, before we do the heating, we're going to put this color crystal, because you can't really see water movement when it's heated. So to allow you to see how hot water and cooler water, how they move inside, we added this substance called the potassium permanganate. It's a purplish substance, okay? In the video, you can actually see it nicer. So then we on the fire. We start heating. Okay, so here comes the main understanding already. So you have to try to pay attention. So as the water is heated up, it expands, right? So must quickly link, when substance expand, the volume will increase, right? Okay, so sound familiar already? And the next point is the mass of the water doesn't change. So I'm going to write here quickly. So when you talk about mass and then there's volume involved, do you remember that this is about density? Okay, so what we are saying here is that when mass is not changed and volume increases due to the expansion, what you're going to realize is this, isn't it? What happened to the density? The density will decrease, isn't it? Okay, the density will decrease, and what it means is that the water that is heated, or the water that is now hot due to the fire, okay, will become less dense. And the understanding will be, if you see the video, it will rise up. The heated water will rise up, and this is shown by the purple coloring moving upward. Okay, watch the video, you can see it and realize it better. Okay, so this is really the part here. So if you go on to part 3 here, of course, the water that's above, okay, they are cooler and denser, right? The word denser came back. The water that's on top here, before the hot water come up, is cooler and denser. So what does it do? The key word here is denser, means the water will sink to the bottom. Okay? So what you can see is that the water that's cooler on top will bring down the purple coloring, okay, as the hot expanded water rise up. Okay, now this is only the beginning. So if we move on to the next part here, so the fire is going, the heating is continuing. So more water will start to get heated up below. Okay, so this process is actually ongoing, and because of this, there is a term used in this case. This movement is then called convection current. Okay, I say again, convection current just simply means the hotter water with lesser density rise up, the cooler and denser water will sink. You can see in the arrows here, okay? You can see in the arrows here. So this is convection current, and this allows heat to be passed or transferred throughout the liquid. Okay, transferred throughout the liquid. And then, of course, this don't finish straight away. It takes some time for the water to be gaining energy, or energy, the heat energy will be transferred in the water. Okay, we have covered the two factors, conduction and convection, for heat transfer. So this is the final method or ways that heat can be transferred, and it's called radiation. All right, so let's get a few important points clear first. Okay, what is so unique about radiation? Okay, let me make sure that you are aware of this first, or I think most of you should be aware. Between the sun and earth, the space is called a vacuum, isn't it? So have you wondered how come we can feel the sun heat? All right, the sun, of course, give us light and heat at the same time. How did the heat and even light travel from the sun through vacuum to Earth? And this is the main point of this part. Okay, it is done by radiation. All this energy from the sun came to us by radiation. Okay, and the main point is this: any energy to be transferred in a vacuum can only be done by radiation. Convection, conduction, they can't. They all need a medium. Okay, and so this is the final, or this is the actual meaning now compared to the other two meaning. What is radiation? The meaning of radiation is the transfer of energy from a hotter body to a cooler body without the need of a medium. In this case, vacuum, no medium. Okay? Okay? So make sure you know the differences between these three methods of transfer. Alright? So if we continue with the second part of this slide, heat energy is transferred by radiation, may be absorbed or reflected. Okay, now the energy from the sun can pass through space, right? Of course, and also through our atmosphere. So radiation can just from space enter into our atmosphere. Okay, then this energy is then of course absorbed or reflected by our atmosphere and also by the Earth's surface. You can then see this very nice illustration of this diagram showing reflection and absorption, okay, of the sun's radiation. Okay, the next slide becomes important. So why is radiation important in our understanding of the Earth? Okay, just now we say that the radiation that is transferring energy from the sun can be absorbed in the atmosphere and on the Earth's surface, but at the same time, it also can be reflected out into space. Okay, of course, right at the beginning, you can see the big two word here, greenhouse effect. Okay, global warming and the kind of thing. Okay, so let's just take a bit of time to understand radiation and this idea of greenhouse effect. Okay, so let's run through it. What do you mean by greenhouse effect? Basically, it's just telling you the warming of the Earth's surface. Of course, when the sun radiation reaches Earth, it will heat up the atmosphere and also the surface of the Earth. Okay, so why is this greenhouse effect so important? Okay, so the only issue is that when the heat is prevented from leaving the Earth atmosphere by radiation. Because every time there's heat entering the Earth, there will also be heat reflected out. But when the reflecting away or reflecting out of this sun's energy is not taking place enough, the heat energy is being kept by the Earth. Okay, and this becomes an issue. But why is this happening? Why is the Earth not able to reflect the sun energy, part of it, back into space? Now, if you read the next part, this is where this idea or this term greenhouse gases, okay, is the cause or the reason. Okay, what are greenhouse gases? They are your carbon dioxide, one of the main greenhouse gases. They exist in our atmosphere, of course, right? But the problem now is that scientists are saying that there are more carbon dioxide in our atmosphere. And what does this carbon dioxide do? It actually traps heat within our atmosphere. It doesn't let this heat to be released into space. And by keeping or by trapping more of this heat, our Earth become warmer. It become warmer, and this has very serious consequence, especially to the life on Earth. Okay, but then how can we increase the release of radiation or the allowed radiation to escape back into the space? So a lot of scientists is looking at how to solve the problem of greenhouse gases. But before we do that, let's look at where do we get the greenhouse gases from? Okay, right? So greenhouse gases are produced, okay, when we burn fossil fuel. Okay, these are the three fossil fuel. Okay, and at this point in time, all these fuel are used in our human activity. Okay, but because we use so much of them, okay, we releases a lot of these greenhouse gases. All right, and because of that, the temperature of our Earth is increasing, and the effect is called global warming. Okay, so this is quite a serious issue that all of us are facing around the world. Okay, so radiation is the greenhouse gases is actually trapping more of the radiation, okay, from the sun. All right, so we really have to be careful. All right, hope this is not too heavy going. All right, see you the next time. These final slides is not so much on radiation, it's a continuation on the effect of global warming. Of course, the understanding will be on radiation, that heat energy from the sun is transferred by radiation through space and then through the atmosphere. But the issue now is all this heat is being trapped, causing global warming. The glacier picture is taken from your textbook, but I added a little cartoon here on the right showing the polar bear standing on a floating ice where you see a hot sun and the thermometer showing the temperature is rising. Okay, we all know this is quite well reported that the North and South Pole, all the ice and even the ice caps, they are getting lesser and lesser. So this will affect the polar bear existence and their livelihood. Okay, so if you continue with the actual content here, so the global warming caused what happened? Melting of the ice cap, isn't it? And also in this case, in the picture, the shrinking of the glacier. Now, isn't it obvious? When the ice, which is water in solid, melts, a lot of this ice become liquid water, right? So where does the liquid water go? Where does the liquid water go? It goes into the sea, isn't it? All this amount of water now from the melting ice is going back into the sea. And this will cause the sea level to rise. Okay? And on top of that, when there's a lot of heat being absorbed by the ocean, okay, by the water in the ocean, then the water will also expand, isn't it? So actually sea water rising has two contributions. All right, one from the melting of the ice in the two poles, and also the expansion of water in the sea or ocean due to the higher amount of energy available. But of course, all this only mean one thing lah. All those coastal area, Singapore of course is an island, will have to deal with the water rising with the sea, and all the coastal area, the land will be getting submerged as the water rises up lah. Okay, so a lot of countries are trying to come up with solution and trying to address this problem. So do you have any idea what are the way we can help to prevent the water from rising and also while at the same time keeping the coastal areas safe and not to be submerged? Okay, think about that. Okay, our government has already been working on it. Hopefully you can read up more and see this is something that we should be concerned about. All right, that's all for this chapter. Take care.